This is a demonstration of Le Chatai's principle and the effect it has on concentration. What we have here is a beaker of deionized water. I'm going to take some potassium thiocyanate, FeSCN, and add 10 drops of potassium thiocyanate to 100 ml of deionized water. I'm then going to take I'm going to add 10 drops of iron nitrate, iron 3 nitrate, to the same beaker, and I've formed rapidly an equilibrium. What I've formed is what's called the iron 3 thiocyanate complex. Iron bonds to the thiocyanate and makes this complex, and this complex is that orangish color. But just to make it a bit darker, 1, 2, 3, 4, 5. I'm going to add a bit more. 1, 2, 3, 4, 5. Make it a little bit more redder so we can see that color. Okay, so what I'm going to do is I'm going to use this as my control, and I'm going to split this 100 mils up 3 ways. So I'll leave this C as my control, and now I have 3 different beakers, each contain the same iron 3 thiocyanate complex. To my first beaker, I'm going to leave it. My second beaker, I'm going to add or impose a change. The imposed change I'm going to add is to increase the concentration of iron. And so what do we see in response? Well, when I increase the concentration of iron, I see the solution becomes darker red. What does that tell me? Well, it tells me that the concentration of the iron 3 thiocyanate complex has increased. This is my reddish substance. This is a yellowish substance. It's actually quite diluted. You don't really see much of it, actually. But that red color we're seeing is the iron 3 thiocyanate. So we would describe this in Le Chatai's principle as a shift to the right. We're adding a reactant, and in response, a system is producing more product. What would we expect to happen if we add potassium thiocyanate, FeSCN, to this one? Well, since SCN- is also a reactant, we would expect 1, 2, 3, 4, 5, a similar response. And that's exactly what we see. We see that this solution becomes darker as we produce more of the iron 3 thiocyanate complex. For the last beaker, I'm going to do something a little bit different. I'm going to add 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. About the equivalent amount of the iron 3 nitrate and sodium thiosulfate to get a deep dark red solution, which makes sense. We're adding both of the reactants. We're shifting this equilibrium to the right to produce more products. Now I'm going to add sodium phosphate. Now, how does sodium phosphate come into it? It's not actually in this equilibrium, so you would think it shouldn't affect it. But here's what happens. Sodium phosphate, being a salt that's soluble, dissociates 100% to make phosphate ion. The iron can bond to the phosphate and form an iron 3 phosphate precipitate. And that precipitate will have the effect of reducing the iron concentration. Now remember, the iron doesn't have much color to it. It's a light yellow solution, but it's not very colorful. So let's add a little bit of this sodium phosphate, see what happens. So drop a few salt. We'll swirl it to let it dissociate, and the solution goes clear. So what's going on in this case? Well, when the solution goes clear, clearly we're losing the iron 3 thiocyanate complex. In effect, the iron 3 cyanate complex is reacting and shifting this equilibrium to the left, trying to restore the iron concentration. But the iron concentration is being reduced by the precipitation reaction. So we've reversed the reaction, got rid of the color, and that's Le Chatelier's principle.